In this section, we're going to learn about the types of electric iron boxes, their construction, function, and attending to repairs in them. The electric iron boxes can be generally classified into two, the automatic and the non-automatic ones. The difference is only that the automatic type has a thermostatic device to regulate the temperature. A turning knob with a dial can be operated to select the preset temperature depending upon the fabric to be ironed. A lamp fitted alongside goes off once the desired temperature is attained. Remember to always disconnect the iron from the power supply while testing with a mega. First, check the electric iron and the power cord visually for any problems. Remove the cover. The components of a dry iron include the heating element, thermostat, and the indicating lamp. The indicating lamp is connected across the ends of the heating element to indicate whether the heating circuit is on or off. The heating element is pressed into its slot on the sole plate. This is the bimetal strip which is riveted to the sole plate. It curls up when heated and breaks the power supply to the heating element through the thermostat. While the neutral wire is connected to one end of the heating element along with the thermostat, the line is connected to the other end of the heating element through the thermostat. When the contact tips in, the thermostat touch each other. The power supply reaches the heating element. When the contact tips are separated by the bimetal strip, the power supply to the heating element is cut off. A thermostat is a switch which can be designed to close or open a circuit at a predetermined temperature. It acts as a safety device to prevent overheating of the electric iron. The heating element indicating lamp as well as the thermostat can be checked individually for their functioning. Connect the heating element across the mega and confirm that it's not open. Next, connect the indicating bulb across the mega and check that it's not open. In a non-automatic iron, there is neither a thermostat nor an indicating lamp to know the temperature of the iron. Power supply is directly given to the flat heating element insulated by mica on either side. An asbestos pad is placed above the heating element to avoid heat dissipation to the upper side. Next, let's study the construction of a thermostat. Basically, it consists of a bimetal strip made of two strips of metal with different expansion rates welded together. While one metal of the strip has a higher rate of expansion when heated, the other has a lower rate. So, when a bimetal strip is heated, the metal at the bottom expands at a higher rate and forces the upper half to curl up, moving away from the contact point. Thus, the circuit gets open. This making and breaking of the circuit controls the heating of the sole plate. Now let's see how to troubleshoot a thermostat physically. Check the adjusting knob for proper fixing and actuation of the shaft. Inspect the contacts of the thermostat for effective contact pressure. If the contacts are pitted or burnt out, clean them if reusable, else replace them. Now, check the actuating mechanism by heating the thermostat with a candle. Turn the knob to the extreme position to check the opening and closing of the contact points. If the thermostat is beyond repair, replace it. Earth clips of the appliance power cord plug should snugly fit into the inner side of the appliance socket to have a perfect earth connection. The problems that can generally occur in an electric iron are no heat, improper heat, blister on sole plate, does not cut off, sticks to clothes, Iron gives a shock. No heat could be caused by any of the following: no power at the outlet, defective cord, defective thermostat, defective heater element, open thermal fuse. Improper heat could be caused by low voltage, defective thermostat. Blisters on the sole plate are caused due to excessive heat. An iron cannot cut off if the thermostat contact points are welded together. An iron sticks to the clothes due to a dirty sole plate, excessive starch in clothes, iron too hot for the fabric being ironed. Shock in an iron is due to disconnection of the earth connection, weak insulation of the heating element, earth continuity with the common earth is not available. Apart from these dry irons, steam irons are also manufactured. Electrically, there is no difference between them. Steam irons have a small reservoir mounted above the heating element. A control valve on this allows the water to drip slowly into the recess in the sole plate. As the water touches the hot sole plate, it is converted to steam and goes out through the holes in the bottom of the sole plate. Usage of tap water instead of distilled water may result in deposits of salt in the tank, clogging the entry and exit points. Leaving the water in the iron for a long period of time results in rust formation. In this section, we saw both the dry iron as well as the steam iron and the procedure to troubleshoot and repair them.